Thank you. Hello, everyone. My name is Alireza. I'm actually going to wear both of my hats today. So first, we're going to talk about my other position as the manufacturing engineer at Old Castle Building Envelope, which is one of the biggest manufacturers of glass in North America, and the implementation of aging device that we have in our plant. So one of the problems that we are facing is that when we are actually cutting a glass, you have to grind it well, polish it well to be not sharp anymore. So we are actually using vertical grinders that we actually always have it here. The most important thing is that in the past, we were having, for example, two racks face-to-face, one operator from one rack, loading one glass, waiting for the glass to be moved by the conveyor underneath to the end of the line, and then the operator should go there, reload it, rotate it, bring it back again on the loading section. And we have to do the same thing over and over. But now we have implemented, actually my slides is a little bit different from what I said, but we have implemented the robotic cell, which is actually going to send get the glass from the first aging device and then put it on the second aging device, and we are going to put both of the operators just standing there, one of them just doing loading and the other one is just doing the unloading, which this is a 60 UF robot. It can lift 300 kilograms, so the payload is about 300 kilograms. Basically, all of them have a limitation, so we have a limitation for the dimensions of the glass that we are using, but the thickness can go up to 20 millimeters, which is super fantastic on its own. And another cool feature is that it has a non-rectangular handling feature, because sometimes when you are doing a repeatable procedure with a robot, so you are pre-programming everything ahead of time. So when the glass is not cut properly, it might damage your machine. But one of the cool features here is that there are sensors embedded inside the machine that when the glass is getting rotated by the robot and putting on the other conveyor, it's actually checking that the glass is sitting properly on the conveyor and then let the glass go, so it can reduce the risks. And most of these agers, including the both agers that I mentioned, they are doing the grinding that we usually do after doing the cut of the glass, and then they can polish the glass, and they can also do the miter, which is basically the flat edge of the glass. And the other important feature that is super important is that the automation is not going to be limited only by implementing a robot in the plant. We are even using the automation even inside the racks. And you can see that both of these agers, they have an automated wheel adjustment setup, which is actually going to make sure that the grinding wheels are always touching the glass, which is a huge problem in the past that we were facing. And also, in terms of the productivity and factors, the length, the weight, and the spacing between the glasses basically are the major factors, which can change everything in terms of the speed. But in total, in terms of financing and in terms of the investment, the ROI, or the return of investment, usually for this kind of things, we had previously doing 15,000 inches per shift, but now we have increased by 3 times by having the same time, which is 3 times more productivity, which can give us back 1.5 to 3 years payback. And another thing is that my second hat, we are actually organizing a medical event in Montreal in 22nd. We did the biggest Montreal event of robotics this year in May 21st, but we are doing another one in medical robotics. So if you're interested, this is the QR code. Please feel free to register, and we would be happy to see you there.